Last week, we learned that the elements were originally grouped together in the periodic table of elements based on their properties, and that they had these properties because of the number of electrons they have in their outermost energy level. We call this outermost energy level the valence shell or valence level, and the electrons in the outermost level, valence electrons. The elements in the periodic table are arranged based on their valence electrons and the number of energy levels they have. As we move from left to right across the table, the valence level has more and more electrons. As we move from top to bottom in the table, the atoms have more and more energy levels. Based on the different properties of elements, scientists have categorized them into different groups. First, we have the most basic groupings, which are metals, nonmetals, and metalloids, also called semiconductors. Metals are solids at room temperature. They are malleable, meaning they can be flattened into a sheet. They're shiny, or at least they're not matte. They reflect light in some way. They're great conductors of heat and electricity, so they get hot really fast and cold really fast, and they can transmit electricity. They're more likely to form positive ions, so they lose electrons, and they take up most of the periodic table of elements. Next, we have the nonmetals. Nonmetals are a mixture of gases and solids at room temperature and one liquid. They're brittle if solid, meaning that they don't bend or flatten like metals do. They're dull if they're solids and don't reflect light. They are poor conductors of heat and electricity, meaning that they don't heat up very quickly. It takes a lot of energy from the change temperatures, and they do not transmit electricity. They're more likely to form negative ions, so they will gain electrons rather than lose them. And they are all on the right side of the periodic table of elements. Well, all except for hydrogen, which is on the left in column 1 because it has only one electron total, so it has one valence electron. So it's in group 1, even though it's a nonmetal. Next, we have the metalloids, which are a little less predictable, but they actually have properties of both metals and nonmetals. We'll talk more about this later. Now we're going to break these groups down even further. Let's start with the alkali metals, group 1 or column 1 of the periodic table of elements. They're soft, malleable, silver, highly reactive solids, and they have really low melting points for metals, which isn't saying that much, but it's low. Next, we have the alkaline earth metals, group/column 2 of the periodic table of elements. They are also silvery and malleable, and they're called alkaline earth because they're actually found in rocks and minerals quite commonly. They're also really reactive, but not as reactive as the alkali metals. Next, we have the transition metals. The transition metals are this big block in the middle, and they're usually what you think of when you think of metals, in quotes, right? This is your gold, your silver, your copper. All of that is in this big middle section. These guys are highly malleable, so they can be flattened into sheets. They have a higher density. They're hard, unlike the alkaline earth metals. And they are also really great conductors of heat and electricity and have high melting and boiling points. Next, we kind of have like a catch-all group. We just call these the other metals. The elements that we really think of in this group are things like aluminum. That is considered an other metal. It has a slightly lower density than the transition metals, but they also just are kind of your typical metals. Next, we have the metalloids or semiconductors. As I said earlier, these have properties of both metals and nonmetals. They're solids. They're often kind of brittle, meaning they don't flatten into sheets or are flexible, right? But they also have things like they can kind of conduct electricity. They are solids, right? Just like the metals are. So they kind of have properties of both metals and nonmetals. Next is our first nonmetals group. These are the other nonmetals. We have a mixture of solids and gases in this group. What sets them apart from metals is, again, they're brittle, so they're not flexible, and they're also really poor conductors of heat and electricity. Really, really poor. The most important elements in our whole lives do actually fall in this group. That's carbon, nitrogen, which is 70% of our atmosphere, and oxygen, the thing that keeps us alive through breathing. Super important. Oh, and also hydrogen. Hydrogen's in this group too. Hydrogen plus oxygen equals water. Also really important. This is an important group. Next, we have the halogens, a super cool group. They're all cool, but these are highly reactive. They form gases pretty easily or exist as gases just naturally. And they also are all kind of colorful. So they're green and purple and brown and yellow. And so that's pretty cool about them. Did I say they're highly reactive? They're highly reactive. Worth saying more than once. Next, we have the noble gases. The noble gases are not reactive. They do not react with things easily at all. Highly unreactive. They're also colorless and are the only gaseous elements that exist by themselves in nature, which is kind of cool. But they are the last column of the periodic table of elements. So from left to right, we have alkaline metals in column 1, alkaline earth metals, column 2, the transition metals in this big chunky portion in the middle. We have our other metals coming in hot. On the right side of the table, metalloids in that zigzaggy thing in the middle. We have our other non-metals. Don't forget about hydrogen over there. We have our halogens. This is in our second to last column, on the right. And lastly, final column, we have the noble gases. And there we have it. These are the groups on the periodic table of elements. Ta-da! Oh wait, did you think we were done? We weren't. One more thing to go over, and that is electronegativity and ionization energy. Electronegativity. This is the ability of an atom to attract other electrons. This is the other cool thing about the periodic table. These things. The electronegativity, it tells us the ability of an atom to steal electrons from other things and to hold on to its own electrons. The most electronegative or best electron thief of all elements on the periodic table is our buddy fluorine. Fluorine is super good at stealing electrons and it's super good at holding on to its own electrons. It does not ditch those things for anything. Next, we have something that's really similar to electronegativity, and that is ionization energy. Ionization energy is the amount of energy it takes to pull an electron off of an atom. So we have higher ionization energy up in the upper right-hand corner and lower ionization energy in the lower left-hand corner of the periodic table of elements. The element with the highest ionization energy is helium. It is the hardest atom to pull electrons off of. So what do these trends actually mean for us? Electronegativity and ionization energy tell us whether or not a atom is going to gain electrons to become an ion or if it's going to lose electrons to become an ion. Atoms with a high electronegativity and ionization energy are more likely to become negative ions, meaning they're more likely to steal an electron from something else than they are to have an electron taken away. Atoms with a low electronegativity and low ionization energy are more likely to become positive ions, meaning that it's pretty easy to remove their electrons, or at least one of them. So that means that their hold on them isn't quite as good. And so they're more likely to lose electrons than they are to gain them. The closer you get to the upper right-hand corner of the periodic table of elements, the more likely something is to form a negative ion. The farther left on the periodic table you go, the more likely something is to form a positive ion. And there we have it. That's it. Have a great rest of your day.